Hey guys, welcome to this new series. In this series, we're gonna be looking at what operating systems are, and we're gonna be trying to understand operating systems in detail so that this knowledge can be used for us to make better software. Before we go into what operating systems are, let's first try to understand what is a program and how a program runs. So what is a program? Program is just a set of instructions that is run by a CPU. Set of instructions in, let's say, if you have a C program where you have int I equal to 0, int j equal to 2, and you have int result equal to I plus j. So what happens is each of these lines is an instruction to the CPU to do something. So the first two lines says that create memory in the RAM and put 0 and 2 as values respectively. The third line says that fetch these values, add them up and put it into new memory C. So each of these lines is a instruction to the CPU, and a set of instructions is what is called as a program. And the way that program is run by the CPU is by taking a program and it executes line by line. So one CPU at any point in time can only run one line. So when I mean CPU here, in our real life example, it means a core. So we have a dual core processor, we have a quad core processor, we have octa core processors, right? It essentially means that you have a processor where you have 4 CPUs or 2 CPUs or 8 CPUs. Each of these CPUs can only run one line of code at a time, one instruction at a time. So this is how programs are run by the CPU. But wait, if a CPU can only run one program at a time, so if you have a 4-core CPU, it only means that you can run 4 programs at a time. But if you use a computer, you know that that's not true. Right? You can seemingly have 10, 20, 30, 50 applications open running side by side, and it works perfectly, right? What is that? How does it work? This is one of the primary functions of what an operating system does. So what operating system is it is a software which is positioned in between your application layer where your applications reside and your hardware. What operating system does it helps our programs run efficiently by interacting with the hardware. Operating systems do a lot more, but this was the starting goal with which operating systems were created. These days, operating systems do a lot more. They interact with hardware devices, they do memory management, they provide security, they do a lot of different things, which we will see in detail. Now coming back to our problem, how can a single CPU or let's say a 4-core CPU run 20, 30, 50 applications if it only has 4 cores? And I am saying that 4 cores can only run 4 different programs, right? Because one CPU can only run one line of code at any point in time. So how does it do it? The way that operating systems enable the CPU to do this, right? CPUs are dumb. All CPU does is the OS tells the CPU, here run this line, here run this line, here run this line, and CPU just executes it. The OS is what decides how to give the programs to the CPU and which program to give and so on. So OS is supposed to be the one which helps the CPU run these many programs even though we're restricted by the number of cores. How does it work? This is one of the most important concepts of operating system called virtualization. What is virtualization? In very, very simple terms, virtualization means illusion. We'll see what it means, but this is the very, very, very simple explanation of what virtualization is. So what do we mean by illusion, right? When I say illusion, I mean the illusion of resources. The resources mean here CPU, RAM, your hard disk and so on. Virtualization of hardware resources, right? Illusion of hardware resources. Not every hardware resource, specific resource like CPU, RAM and hard disk. So let's take virtualization of CPU as an example. What virtualization of CPU means is that, again, as we saw, right, let's assume we have a 1-core CPU. In today, these days we have 2 core, 4 cores, 8 cores, 16 cores and so on. But for simplicity's sake, let's assume we have a 1-core CPU. So your OS feeds in lines of a program to the CPU and the CPU executes them. But even if you have a 1-core CPU, you could run more than one program at the same time. How does it happen? The way it happens is that the OS tricks the programs by making them see that they have their own CPU. So if you have 2 programs, for each program, it looks like it has its own CPU. So if you have 2 programs, for each program, it looks like it has one CPU. But in reality, both of these programs are sharing the single CPU. But what? This makes no sense. Yeah, I understand this makes no sense, but this is how the operating systems enable multiple programs to run at the same time. How it does this is something that we will look in detail. We will have many more videos which will go into the depths of virtualization and how it happens and so on. But this is what OS does. I understand that it's something that very hard for us to visualize, but this is how CPU is virtualized. Similarly, for RAM, let's take RAM. So how is physical RAM? So you can imagine physical RAM like an array of bytes, right? So let's say you have a 4 GB RAM and you have a massive array of, let's say, 10 entries, and each entry is some MBs. This is how physical memory is there. So let's talk about how memory is virtualized, right? This might help you give a little bit of picture. So how is physical RAM structured, right? The way you can think of physical RAM is like an array of bytes, right? As simple as that. So each element in the array has an index, which you can think of as the address of that particular segment of memory. So if you have an array of, let's say, 10 segments, the first segment's address will be 0, the second segment's address will be 1, the third segment's address will be 2, and so on. So now when a program runs, so let's say you have a 1 GB RAM which is split into 10 segments. Let's say, for example, this is not how it is, but for example, for understanding, let's say we have 1 GB RAM which is split into 10 segments. Essentially, it means that you have an array of 10 entries and each index is like an address to that segment in the memory. So let's say now you have two programs which wants RAM. What happens is these programs don't write to the RAM directly. I mean, they do, but for them, the way it looks is that, so the operating system splits this 10 segments into segments of 5 and it makes virtual arrays. Arrays, when I mean arrays here, I mean memory. We're taking array as an example for memory. So it makes virtual memory, which makes it look like for each program, it has its own memory. But in reality, both the programs are sharing this common physical memory. For program 1, you have 0 to 4, and for program 2, you have 5 to 9. So for each program, now if you see, it looks like each program, from the perspective of the program, it looks like the program has its own memory, but in reality, it is shared between both the programs. So this is what I mean by virtualization. Now this virtual memory is called as the virtual address space. If you've been in software engineering for a while, you would have heard the term address space a lot. This is what the address space is. You would have heard heap space, heap memory, stack memory, and so on. All of this is part of the virtual address space. So this is how the OS tricks the program by saying, hey dude, you have your own memory, now do whatever you want with it. But in reality, the memory is actually shared by multiple programs. This is how memory virtualization is done. So I hope these examples give you an idea of what virtualization looks like. Again, I know there are a lot of questions. We will be going into how operating system exactly virtualizes the CPU and memory in detail as we go on. But for this video, it's very important to understand this is the concept of virtualization. What is virtualization? How is something we will be going in detail. So to recap, virtualization is just illusion of resources so that it looks like each program has dedicated resource, but behind the scenes, they're actually sharing the resource. So I hope the concept of virtualization is clear. In the upcoming videos, we will be going deep into how virtualization works, how the operating system virtualizes the CPU, how it virtualizes the memory. And virtualization is just one part of what operating system does. There are two more parts, namely concurrency and persistence, which is also something we would go into. So this is going to be a massive series. If this topic interests you, like, share, subscribe, and I'll see you guys at the next video.